Congratulations, everybody. You made it through your 8th grade year. This is actually going to be the last video that you would be required to watch in your 8th grade year, and it is the last video that I will be giving for the CLEP test practice. There is one more practice test, but the answer key for that one is not in video form. And I thought today I wanted to do something a little bit special. Instead of a pun, I thought I'd just give you, a real story that didn't have some big joke at the end of it, And so someone was talking to me yesterday, or today, sorry, and I wasn't paying attention, as I normally do, and I was thinking about something else, and they asked me how I was, and I replied with watering hole, and what I really was going to say is well. So it's just something there. Question 1, once again, is about inserting some inputs and figuring out what the outputs are for our function. Since we've done these before, I simply gave the answers for each of these. Once again, if you use the TI-84 graphing calculator, they're definitely not too bad. Just be careful. And if you have any questions on how to use the TI graphing calculator for each of these, make sure you let me know, and I would love to help you. Okay? Let's move to solving equations. So for solving equations, the first one I did for you, excuse me. So we added 3 to both sides, and then we divided by 2 to everything, and we ended up with 1x is equal to 10.5 or 10 5/10. Either option would be just fine. I'm going to solve the one on the right. Showing each step. A couple different ways you could solve this, but I'm going to subtract 2 from both sides first. I get 3x on this side. I get 12 minus 5x on that side. I'm now going to add 5x to both sides. I get 8x equals 12. From here, I divide everything by 8. And so x is equal to 1.5, if I am correct. 1.5. Okay, let me check my answer key. Yep, that looks right. So, couple more solving equation problems here. This one has the distributive property in it right away, so make sure that you're careful with the distributive property. Your end answer is still a fraction or a decimal. I wrote it as a fraction. For this one, I'm going to subtract 6 from both sides, giving me negative 2/3 x is equal to 8. Now you could, if you're using a calculator, divide both sides by negative 2/3 pretty quickly. You could obviously divide the fraction by hand, but if you are not a fraction fan, you can always multiply both sides by 3 to get rid of the denominator. And then you can divide everything by negative 2 to get x is equal to negative 12. Okay, checking my answer key. That one is correct. Moving right along, we are now going to graphing. So it wants us to graph using slope-intercept form and using a table. So in the last video, I talked about using slope-intercept form to help you make the table. We're going to do that again. So these are our points. So 6 is right there. And I'm going to go down 2 and over 3, and I can do that as many times as I want. And from here, I just have to graph my line. It wasn't the greatest line, but definitely not my worst either. So, if we wanted to make a table, that wasn't great either. So our first point here could be 0, 6. Our next point could be 3, 4. Then we could do 6, 2, 9, 0. And I could continue this on as far as I wanted to go. It just depends how many points it's being asked. Now, I could also just do -2, -1, 0, 1, and 2 like I've always done. You would just get fractions for your y values, which is fine. There's nothing wrong with that. Most of us, though, are probably going to be looking for the fastest way, which would mean this method that I just showed you. For the next graph, I did this one for you. The only big difference is right here. You needed to solve for y right away to get it into slope-intercept form. Once you have it in slope-intercept form, then you're able to graph it. So if you do not have it in y= form, cannot graph it, substantially more difficult for you before you get to that step. And let's do one more before I pause here. Turn the following into slope-intercept form. So this is very similar to what we just did, except including some harder numbers. So for the first one, I did the distributive property. And then I subtracted 2 from both sides, giving me the slope-intercept form down here. The problem on the right, I have to do the distributive property again. But this is now going to give us a fraction. Now, this is 1/4. So 1/4 times 3 is 3/4. And 1/4 of 4 is +1. Fraction here is just fine. So I'm going to add 5 to every number, and I get y = 3/4 x plus 6. I am now in y = form, and I am done with this problem, and that makes me done with problem 4. Question 5 is on line of best fit, and actually has the potential to be one of the harder questions on the practice test if you are not prepared for it. So I managed to misplace my answer key for this one, but that's okay. What I have here is my graph. Took my data and I put it into my line of best fit form. On this graph, I did age as the x value, cost as the y value, and now I just have to graph my line of best fit, which means I want to get as close to as many points as possible, but I don't actually have to go through all of them. So I'm going to try right about there. That looks pretty good for my line of best fit, which means that I would say my b value is pretty close to 9,000. Obviously, there's some estimating going on there. And then I need to find a good slope. So let's say if that's at 9,000, and let's go to this point here, which is about 16,014. So that means that I'm going up about 7,000 from here to here, and I'm going over 14. Oops, 14 and 14,000. Well, 7,000 divided by 14 is about 500 for my slope, which actually looks pretty good, because if I'm looking from like this point to this point, I'm going up about 1,000. I'm going over about 2 years. So that would make sense, about 500 per year. So giving me my form is 500x plus 9,000. And of course, at this point, if I plugged in each of these numbers, you know, like this one, I would get 10,500. You know, that's actually pretty close. So a lot of these is, you know, this would be 12,000. You're just trying to get really close to the actual data and making sure that what you've created would make at least some mathematical sense. I will tell you, on the CLEP test, the line they're looking for is pretty clean, like this one. They're not going to be looking for something with 45 decimal points or anything nuts like that. So rounding like I've done in this problem would be just fine on the actual CLEP test. For the average, all we're doing is we're taking the average of all of the x's as the x point, and then the average of all of the y's as the y point, and then you're making that an ordered pair. Okay? And then usually you'll notice that your average should end up really close to being one of the points on your line, which it does. Let's move on to the next one. So for the following system, solve the problems all three ways. That means adding, substitution, and the graphing method. Now, the graphing method is probably the fastest one, which means we got to put each of these into y equals form. So for my first one, I would get y equals negative 2x plus 3. And I'm shortcutting that a little bit. And then the bottom one is a little bit tougher. That's going to be y is equal to positive 2/3 x plus 1/3. So got some fractions here. But I did graph them, and I noticed that they intersect at the point 1, 1. So, now in order to do the substitution method, I don't want to do this one substituted for that y there, because I think that actually gets pretty crazy with some fractions involved. So I'm going to take this y and substitute that value right there. Okay? So I'm going to do 4x minus 6 parentheses, and now I'm going to substitute in this value, negative 2x plus 3, and that's going to be equal to negative 2. I'm going to distribute negative 6, so I get 4x plus 12x minus 18 is equal to negative 2. I'm going to add 18 to both sides. And I get 16x equals 16. So x is equal to 1. I can substitute this one anywhere. I'm going to substitute it up here. So I'm going to get y is equal to negative 2 times 1 plus 3. That's negative 2 plus 3. My y is equal to 1. Which is good because that's what we wanted in the first place. And now we need to do the addition method. So what I'm going to do is I'm going to do the top equation times negative 1. Let's do the top equation times negative 1. So I'm going to get negative 4x minus 2y is equal to negative 6. Bottom equation I'm going to leave as 4x plus 6y equals positive 2. Something does not seem right here. Let me pause and figure it out. My bottom equation was incorrect. I was multiplying times positive 1. So that should be still negative 6y, and this should be negative 2. There we go. Now when I add them together, I get negative 8y is equal to negative 8. I get y is equal to positive 1. And from here, I can do the same substitution strategy I did over there, but in reverse. But all three methods, I end up getting 1, 1 as my point of intersection. And that's it. That's the end of the systems of equations. And like I said before on the CLEP test, the systems of equation problems are not going to be the hardest that you've had all year. This difficulty is about as hard as it will get. Just be careful with the substitution method because it will ask you to do the substitution method on a problem directly. You will have to do that. Let's do some probability. So rolling a 4 on a 6-sided dice, well, there is 1 4 out of 6 sides. That is equal to about 17/100ths or about 17%. Rolling a 13 on a 20-sided die, well, there is 1 13 on 20 sides of the dice. That is about 5/100ths or about 5%. Pulling a black jack, well, there are 2 blackjacks, jack of spades and jack of clubs, out of 52 cards total. That's going to be equal to 1 out of 26, which is about 4/100ths or 4%. And finally, pulling a queen from a 52 card deck. There are 4 queens out of 52 cards. That gives us 1 out of 13, or about 7/100ths, or about 7%. Double checking my answers. We are correct, and we are ready to move on to factoring. So, it wants us to solve using both factoring and the quadratic formula. So, step 1 here is we're going to subtract 4 from both sides because we need this to be equal to 0. So, plus 8x plus 7 is equal to 0. So my factors for c, because my a value is 1, are 1 and 7. And 1 plus 7 equals 8. So that means we are going to do 1x plus 1 and plus 7, giving us x is equal to -1 and x is equal to -7 as our answers. Now, I'm going to pause this and do the quadratic formula over here on the right for you. So, I did the quadratic formula. I ended up getting -8 plus or minus the root of 36 all over 2, which makes sense because we had non-decimal answers, which gives us this. And I converted it over here on the side to give us our answers of -1 and -7 once again. So now let's move to the one problem on the CLEP test that will have required you to do Q6. So I'm going to erase all of this. There's lots of room. So now we need factors from our C value and we need factors from our A value. So our factors from our A are 2 and 1. Factors from C are 1 and 20, 2 and 10, and 4 and 5. And we are trying to create +3, and we know there's going to be some subtraction involved somewhere. So I need to create +3, and I think I see it with these pairs of factors because I want to get 8 minus 5. And I create 8 by doing 2 times 4, and I create 5 from doing 1 times 5. So I have all the information I need to write out my factors. So the number in front here is 2. So I'm going to do a 2b and a 1b. Okay. So now I need this 2 to be multiplied by a 4. Okay. So I'm going to put that 4 here because then it's going to be multiplied times that 2. Then I need a 5 to be multiplied times a 1. So I'm going to put the 5 here. However, the minus sign needs to be with the 5. So I'm going to put it right there. Now, this is what I recommend you do on the CLEP test. Re-multiply it out to make sure you got it correct. So 2b squared minus 5b plus 8b minus 20. And that is correct. Because if you multiply it out and it doesn't work, just shift around your factors to make sure that you got them correct. There's nothing wrong with doing a simple guess and check to make sure that you actually have your factors correct. And you could get your factors correct by doing simply guess and check. It would be extremely possible. It just would not be fast. Okay? Once again, I'm going to pause the video to write the quadratic formula here on the left side. One of the really nice parts about doing the quadratic formula and factoring is you can catch your mistakes. So I actually forgot to divide by 2 on this problem, and I caught it here because I created 10 over 4, which is the same thing as 5 over 2 when I did the quadratic formula. However, the one on the right, I didn't make any mistakes, and that ended up being -4, excuse me, both ways. And that is as hard as the factoring / quadratic formula would get on the CLEP test. We are down to the hardest problem on the CLEP test, which is the one that's going to kind of mix quadratic formula, factoring, polynomials, all of it's going to be mixed together. And it's always going to end up in this same format. You're going to have question 1. It's just going to ask you to plug into your equation, okay? Now, you're also going to usually, and this is where I would really be focused if you're someone who wants to pass the CLEP test, you're going to be given something that looks like this, except you're going to have to substitute one variable in. So it's going to give you the velocity, and you're going to have to substitute it in for v first. Now, I gave it to you, but it's the same process. So don't get thrown off when it gives you a problem like this, and it gives you multiple numbers. One of those numbers you have to plug in. Then it asks you to solve for the height after 1 second, which we did right there, and we ended up getting 12 meters tall. Last time Beck caught a mistake where I had this in feet instead of meters, but I double-checked my labels this time to make sure that did not happen. Then we get to the hardest question. We'll ask, like, how high will the ball be after a certain number of meters or feet or something? Okay, so you could guess and check that because the answer could be a whole number, but it's going to be so much faster to just simply substitute the 8 in for your last or your equal to, and then solve the equation. So that means we're going to have to subtract 8 from both sides. And we're going to get, and I'm going to write this in descending order, 5t squared plus 14t minus 5 equals 0. Gives me an a value of -5, a b value of 14, and a c value of -5. And then I need to do the quadratic formula from here, okay? So I'm going to switch colors. And we're going to do x is equal to -14, so opposite b, plus or minus, I've forgotten here, the square root of b squared, which is 196. 14 squares, 196 minus 4 times a, which is -5, times c, which is also -5, all over 2a, which is -10. Okay, so now 4 times 5 is 20. Negative makes it positive 20. Times -5 again would be -100. So that'd be 196 minus 100 is going to be square root of just 96 all over -10. Now, my assistant, who is about as good as Mr. Maxwell's assistant, so I would double check this, tells me that the square root of 96 is really close to the decimal 9 8/10. So my two numbers would be -14 plus 9 8/10 all over -10. Or it would be -14 minus 9 8/10 all over -10. And then if I plug these into a calculator, which once again my assistant did for me, or maybe it was Mr. Maxwell's assistant, either way, I would double check, gives us positive 42 seconds, or 2 38 seconds. And this makes sense, at least in theory, because when you have a ball that is going to be flying through the air, okay, you want to think that ball, unless you're hitting the peak, it's going to hit the height once, go above it, and then hit it again on the way back down. So it goes up to 8 meters at 4200 seconds, hits its peak of the throw, and then comes back down at 2 38 seconds. So this would at least make sense, once again, if the assistant did those calculations correct. So make sure you double and triple check those. For the bottom question, then, when will the ball hit the ground? This was actually the same as the first one, because if you want to know when the ball hits the ground, it's always going to be equal to 0. So once again, you do the quadratic formula. There are two options. Only one of those options is going to make sense, because this gives us a negative number, which doesn't make sense for time. So then at 3 seconds would make sense. So up here, this answer is even better, because we know that it's coming back down at a little bit over 2 seconds, and then it hits the ground at 3. So that would make me more likely to believe that this answer is correct as well. Okay? And then the CLEP test ends with kind of some gimme questions if you remember your factor or your exponent forms. So all we're doing is we're rewriting this term twice or we're distributing the 2 into every term. So we do 2 squared, which is 4, x to the 5th squared, which would be x to the 5th twice, or x to the 10th, and then we do y squared squared, which is y to the 4th. If we remember that everything inside the parenthesis raised to the 0, anything raised to the 0 is not 0, it's 1. Somebody is going to write 0 on the CLEP test, and it's going to make Mr. Schmidt really sad, so please don't do that. Anything inside this is going to be equal to 1. Then we have 2 more problems, which I wrote out for you. I would once again double check those to make sure that I did everything correct, but I believe that that is every problem on the practice test. There is one practice test left. That one will, like I said before, not have a video answer key. It will have a paper answer key, and I will have that posted online for you probably Monday, maybe Tuesday. But it will be ready to go to make sure that you are ready to take your test on Wednesday, June 5th.